Hi, I am Varun Joshi and welcome to day 14 of our Certified Kubernetes Administrator 2025 course. Today, we'll dive into Kubernetes namespaces, exploring why and when to use them. We'll look at how namespaces help isolate workloads, manage resource segregation, and avoid naming conflicts within a cluster. I'll walk you through creating, managing, and using namespaces, and we will wrap up by setting a default namespace using Kubernetes contexts to simplify our workflow. Let's begin this with an analogy. What I have on screen is I have a house without rooms, and we have multiple families living in this house. When there are no rooms, there are challenges with this house. There is no privacy, no security, or any sort of organization. But when I create or build rooms in the house and allocate one room to one family, then we have something called privacy, security, and organization. Similarly, what we have been doing up until now is we have been creating and deploying resources in a single namespace. Hence, there is no privacy, no security, and no organization. You can think of this house as Kubernetes cluster and these families as workloads which we have been deploying. In this example, you see we have 4 applications and all these applications are deployed onto the default namespace. Is there a problem with that? Can you do that? Of course you can do that. Is it a good practice to do that? No, it is not. Hence, this is an improved design. Here we have a Kubernetes cluster and then we have designated one namespace per application. Application 1 is deployed in namespace 1, application 2 is deployed in namespace 2, and so on. So now we know why we need namespaces. We need namespaces to have proper segregation in our workloads. Now let's see what is a namespace. A namespace in Kubernetes is a logical partition, like namespace 1 is a logical partition, namespace 2 is logical partition, and so on within a Kubernetes cluster that helps organize and isolate resources. In this example, app 1 is isolated from app 2, app 3, and app 4. And similarly, application 2, 3, 4 are also isolated from each other. Let's see what are other benefits of namespaces. First is isolation and security. And how security? As we move on with this course, we learn about network policies. That you can have advanced network policies which will explicitly deny certain communications. Second is resource management. Let's say I have been given the responsibility of chargeback and showback. So chargeback implies I should be able to charge different departments based on how much resources they are using. Showback is I could see how charges are incurred for that specific department. What I can do with namespaces is I can say app 1 namespace can use 100 GB of memory. However, app 4 namespace can only use 50 GB of memory. And I'm using memory as example, but you can do these permutations and combinations based on storage, CPU, number of pods, and there are plethora of things. And these things can be achieved by using a combination of resource quotas, requests, and limits. All of these we'll see later in this course. Third is application project environment segregation. What we have done here is we have segregated our applications based on namespaces, but do not limit your imagination to just this scenario. App 1 is deployed. App 1 could have a development environment, a UAT environment, and a production environment. You could create 3 namespaces here: app 1 development, app 1 production, and app 1 UAT, and relevant resources can be deployed onto the respective namespace. A level of segregation is project as well. Maybe I have app 1 for HR department, I can have a namespace for HR, I can have a namespace for finance, and so on. Access management. When someone is accessing our Kubernetes clusters, let's say Varun manages the infrastructure for application 1, then Varun can only be allowed to access resources that are present in application 1's namespace. So hence, namespaces also helps in authorization, hence access management. The last one is workloads naming. I said that application 1 can have 3 different environments, and those environments can be segregated into namespaces. Namespace app 1 development will hold development related resources, and similarly prod will hold prod and UAT will hold UAT resources. But I can create Kubernetes objects with the same name. For example, app dev namespace can have a deployment named app1. Similarly, the other namespaces can have the same name for the deployment. If I were to use a single namespace, I cannot have 2 deployments with the same name. Hence, workloads naming can also be achieved using namespaces. I gave an example of deployments, but the same implies for services, secrets, config maps, and any other Kubernetes objects. When you divide your resources into namespaces, you can have the same name across all the namespaces, and that is the benefit that namespaces provide you. Now let's do one thing. Let's directly go to the terminal. I'll quickly clear my screen. I will run kubectl get all. I see there is a service created. The name of that service is Kubernetes, and this is a default service that you will always see. I'll add -a here. What -a will do is -a will list down all the resources available in all the namespaces. So I'll hit enter, and you see here I see the namespace name and it says Kube system, and there are other namespaces as well. We see 2 namespaces here. I wrote -a uppercase. I can also write all namespaces, and these flags will work when you write kubectl get pods, kubectl get service, or deployment, or any other object for that matter, as long as that object is namespaced. We will see why I'm saying this, whether the object is namespaced or not. I'll hit enter here. Namespaces. Oh, I should have 2 hyphens here, and I'll hit enter, and I see the same output. -a or -- all namespaces will give you the same output. Now let's do one thing. Let's clear our screen, and I'll write kubectl get namespaces. I'll hit enter. I see there are 5 namespaces in this Kubernetes cluster. So let's first understand what are these namespaces. I'll quickly go to my GitHub repository, which you should be referring a lot when you are revising things. Watch the videos and then revise the concepts using the GitHub repo. It holds all the information in detail. So whatever I'm speaking, even if I miss certain things, I'll add that in the GitHub repo. So ensure you check this out. And let's see the definition. The default namespace. Kubernetes includes this namespace so that you can start using your new cluster without first creating a namespace. Whatever resources we have been creating up till now, all these resources have been created in the default namespace itself. Second is the kube system. Kube system is there to hold all the control plane components. There is kube public. This namespace is readable by all clients, including those not authenticated. Publicly accessible data primarily used for cluster information. Then there is a kube node leads, heartbeats of the node in the cluster used by control plane for node health. Why are these things segregated? For the same reason we discussed before. We want isolation. We don't want any command to delete our control plane components, which is why Control plane is there in a separate namespace itself. Same applies to the kube public and kube node release. Since we are using kind cluster, we also see a local path storage namespace. This namespace is associated with persistent volumes. We'll create persistent volumes when we move to the storage section of this course. We know kubectl get namespaces will get us all the namespaces. Now let's write one more command, kubectl API resources. We have used this command before as well. This will show you all the objects along with their kind and short names. If I write here and I scroll up a little, I should see namespaces. Let's do one thing. Let's do smart work. I'll just search for namespaces. I'll add -i. I'll write here ns. ns is the short name for namespaces. I'll hit enter. This should be written with kubectl API resources, and I see that here are namespaces. The short name for them is ns. v1 is the API version, and namespaced is false, and their kind is n with uppercase namespace. So let me do one thing. Let me first get all of them. If I move up, you see that there are certain Kubernetes objects that are namespaced, and then there are certain objects that are not namespaced. Namespaced is false here. So let me do one thing. Let me write here, let me filter the resources. I'll write namespaced is equal to false. So whatever objects that you see here, they do not belong to a specific namespace. For example, let's say I created a namespace called, let me go back here. Let's say I created a namespace 1 for application 1. If I delete this namespace, anything that belongs to this namespace gets deleted. So the deployments, the secrets, config maps, whatever was associated with this namespace will get deleted. But there are certain Kubernetes objects that do not belong to a specific namespace, that belongs to the Kubernetes cluster altogether. All these objects that you see here, they are not part of any namespace. So nodes, so you see here we have 3 nodes, kubectl get nodes. We have 3 nodes here. These 3 nodes do not belong to a specific namespace. They are for the Kubernetes cluster itself. So we'll soon create cluster role bindings, priority classes, and then there are also persistent volumes. So these things you see here, they do not belong to any namespace, which is why namespaced is false for all these Kubernetes objects. Now let's do one thing. Let's create a namespace and then deploy our front end and back end into that namespace. So what I'll write is kubectl create, very simple command, namespace, and I'll write -h here. -h says it will give me an example that you can simply write kubectl create namespace and then give the namespace that you want to create, and the namespace will be created. As simple as that. So what I'll do is I'll write kubectl create namespace. I'll name my namespace app1-ns. ns is the short name for namespace, and usually whenever I create a Kubernetes object, I add what kind of object I am creating against that as a prefix or suffix. That's my habit. Kubectl create namespace app1-ns, and then I'll write dry run is equal to client. This will not create the resources, but it will tell you what this command will do. If I press enter, it tells me that namespace app1-ns created. In parentheses you see dry run. This implies that if you run this command without the dry run is equal to client, your resources will be created, your namespace will be created. I can also write server here. This will verify this command against my API server as well, and it will also check for the Kubernetes full schema. The previous command only checked the basic Kubernetes schema. Now what I'll do is I'll write dry run is equal to client here, but what I'll do is I want the output in YAML format, and you send this output to app1-ns.yaml. This is my file. So what I am saying here is do not right now create the namespace. This is just a dry run. I want the output in YAML. Let me just spell correct this in YAML. and whatever the output is, you redirect this to this file. I could have not written this and I could have ran the command and this would have created the namespace, but I also want version control, which is why I am extracting this into a file. I'll press enter now. This should have created a file. Let me first see in which path I am. Oh, I am not where I want it to be. So let me do one thing. I'll cd into CKA. Then let me see what I have here. Oh, this is something else. Let me hit back. I'll just quickly copy the path where I want to be. ls, it is in cd, reveal in finder, it is user Varun Joshi courses. Okay, we have to go in Varun Joshi courses, CKA, cd courses, CKA. I want to go in day 14. Yes. Now let me recreate that file because I want that file to be in that path. I'll press enter. I'll go to my Visual Studio Code. I already have day 14 here. I'll expand this. I'll go to app1 namespace.yaml. What? That simple. Let me remove the unnecessary part and this as well. I'll remove it. This is the YAML for namespace. It is that simple. It only has 4 lines. If you see here, I'm naming my namespace and kind is namespace like we saw in kubectl API resources command, and then API version is v1. Now I'll go here, I'll clear my screen, I'll write kubectl apply -f, I'll call the file name app1ns, I'll hit enter. It says the namespace is created. Kubectl get namespace. It shows me that the app1 namespace is now active. What we'll now do is we'll deploy both backend and front-end deployments and services in this namespace. For anyone who has joined us only for this lecture, I quickly want to show what we are doing. We have 4 Kubernetes objects here. We have backend, we have front-end, then we have backend service, and we have a front-end service. Backend service is of type cluster IP and front-end service is of type node port. We have 2 deployments. The backend deployment is running an HTTP echo image. This image will just output hello from backend. This, to maintain simplicity, we are using this. In actual production grade deployments, the backend is your application tier, which will hold the application logic, and then we'll also have a front end. This front end is your typical Nginx image that is just displaying the default page for Nginx. We will have a node port service that will be fronting the front end deployment. So we'll create this infrastructure in that namespace. I already have the deployment files. I won't be writing them from the scratch. I'll quickly show you. This is the backend deployment. We have 3 replicas. This will create the pods with labels app is equal to backend, and this deployment will pick any pods that have app is equal to backend label, because the selector for this deployment is app is equal to backend, and this is the text that will be displayed once I access this container, this pod on port 5678. This will also create a backend SVC. This backend SVC listens on port 9090, the target port, that is the port on which my pod and my application listens on. The application listens on port 5678. The selector here is app is equal to backend, which is why this service will manage all the pods, will load distribute to all the pods that have app is equal to backend label. Now let me do one thing. Let me quickly go to the CLI. I'll write kubectl apply -f backend. I won't hit enter right now, because if I press enter, it will deploy this deployment and service in the default namespace. Remember, we want this to be in the app1 namespace. So I'll add a flag here, -n is app1 namespace. If I now press enter, this service and this deployment will be created in the app1 namespace. So I'll run kubectl get deployments, and I want the deployments in app1 ns, and you see there is a backend deploy already created. I can do something similar for service as well. If I write svc, it will list me the backend service as well. I hope this is understood. It is very simple. Let's create a front end with a twist. Right now what we did was we just ran this command and it deployed this in app1 namespace. Now how do I specify the namespace in my YAML itself? In front end, what I want is I want to specify the namespace in the front end itself, in the deployment itself, in the service itself. So how do I do it? So let me just open the backend as well here so that we can have a side-by-side comparison. We have already deployed the backend and we now want to deploy the front end. Let's see where can we place the namespace field. We know that when you have a deployment or any object running, you can extract the YAML from the running object using -o YAML. So let's see that command. I'll run kubectl get deployment. I will write the name of the deployment, but I'm typing B, but tab completion is not working. It is not working because tab completion is searching in the default namespace. So what I'll write is I'll write -n, app1 is the namespace. Now if I press tab, it auto completed using backend -deploy. Now I will write here -o YAML. If I had to extract this to a file, I could have provided the file name as well, like test.yaml. But right now I can do away by getting the output on the screen itself. Now this has many fields. You can, if you are creating a YAML, you can delete the fields that you do not need. But right now I just want to see where do I write the namespace. If I see API version, kind, metadata, and inside metadata you have annotations, and in that you also have name, and namespace is also specified under the metadata section itself. So I'll go to my deployment, I'll press enter here, I'll add namespace is app1 -ns, and similarly in service as well I'll add namespace, and the namespace will be app1 -ns. I'll save this. Now I'll go to the terminal again, I'll clear my screen, and now I can just write kubectl apply -f frontend deploy.yaml. I'll press enter and it says that the resources are created. What I'll now do is I'll run kubectl get all -n, and the namespace will be app1 -ns. I'll press enter. I see that all the objects related to front end and back end are deployed in my app1 namespace. Now what is happening is with each command I am supplying -n app1 namespace. This is decreasing my productivity because every time I want to see something I have to write the namespace name. There is a way via which you can fix this. Not fix this, you can increase your efficiency, so to speak. So if you remember, in day 8 we discussed something called Kubernetes context. Students who have not seen the video for day 8, I would encourage you to do it. I'll just give you a small crux here. There is a kubeconfig file in Kubernetes that deals with authentication. Okay, it has 3 main sections: user, cluster, and context. User is who is accessing the cluster. Cluster is which Kubernetes cluster to access. So if I am accessing something from my laptop should know which is the Kubernetes cluster I want to connect. When I say my laptop, I'm implying the kubectl client that I am using to interact with my Kubernetes cluster should know what is the address for the API server. How can I reach that API server? So that information, the information about the API server, is in the cluster part. Context is something that maps the user to the cluster, and in the context itself you can specify the namespace that you want to access, that you want to be the default when that user runs certain commands. So if I go here and I write a command kubectl config view, I'll add --minify. Now this is saying clusters. I have information about one cluster, and that cluster is named this, and that cluster can be reached at this address. Then there is context. Context is something that maps the user to the cluster. Let's first see users then. User, the name of the user is kind my second cluster, and this is the authentication information that this user will use when it wants to connect to the cluster. So context is that joins the user and the cluster information. This will make more sense if I go here and show you day 8. Here we saw that this is a kubeconfig file. Now there are 3 clusters in this example. What we are saying is, if our cluster 1 is dev cluster and we have created a dev context for it. Dev context says whenever user chooses to use this context, the cluster that you are supposed to use is cluster 1. So we see that here we have information about cluster 1, and the user that you should be using is Varun user, and in this kubeconfig file I only have one user. So in this example, Varun user has access to 3 clusters. Whenever he wants to access a specific cluster, he can just change to that context and access that cluster. For example, if Varun wants to access dev cluster, he can switch to dev context. If he wants to access a staging cluster, he can switch to staging context. Similarly, if he wants to access the prod cluster, which is cluster 3, he can switch the context to prod context. So in this example, since we are using kind, we only have one context, and that context is named kind my second cluster. This is not a best example because kind has named everything the same. So the cluster name is also this, the user name is also this, and the cluster name is also this. So which is why it is confusing. Hence I have shown you this kubeconfig file, which should have put things into perspective. Now let's go back to the terminal again. What we'll now run is we'll write kubectl config set. Let me show you -h. What are the options here? So what we will do is we'll set the context, config set context. We'll say the current context, the namespace that you should be using is app1-ns. Here we are specifying the namespace, but if you want to switch contexts, you should refer this GitHub repository, and you can use kubectl config use context to switch between context. And once you have switched to a context, then you can set the namespace for that context, which we are doing here. We are saying that kubectl config set context, the current context should point to namespace app1 namespace. I'll now press enter, and once I do that, if I run kubectl get pods, it will get me the pods in app1 namespace without specifying -n. So this is how you set the namespace. And let's do one thing. What I'll now do is I'll set it back to default, and if I now run kubectl get pod, it should say there are no pods in the default namespace. Now let's do one more thing. I'll write kubectl run test pod. Image that I want to use is busybox, for example. I'll write -it. I'll also write -rm so that once I exit this, the pod is deleted, and then I'll write I want to access the shell of this pod. I'll press enter now. I see that we are in the pod. Now let's curl backend svc :9090. 9090 is there because backend, the service that we have created, the cluster service that we have created for backend, listens on port 9090, and once we reach the cluster IP in this port, it will forward the request to the target pod of any of the available pods. Let's go there, and I'll press enter. Oh, it says the curl is not available. So let me exit this, and let's use nginx pod because nginx will have curl installed. I'll hit enter, and I'll now curl backend -svc 9090. Could not resolve host backend SVC. Why is this? Can anyone guess it? Let me do one thing. Let me open another tab here. I'll zoom in. I'll write kubectl get pods. It says that the test pod is running. Why is it not able to access our backend? It is not able to do so because the test pod is in default namespace, but our application is deployed in a separate namespace. Let's exit this, and as soon as I exit this pod, this should be deleted. And if I run kubectl get pods, you see there is no pod because we used --rm flag. What I'll now do is I'll run the same command, run test pod image nginx, but I'll write one more flag here, -n. I'll say app1 namespace. I'll now press enter. I'll again press enter. Now I'll write curl backend SVC :9090. If I press enter, hello from backend. This works. This works because this pod is in the namespace where backend and frontend deployments reside. If I now go to my Chrome browser, if I access this on localhost port 31,000, then I'll see the nginx page is also accessible. Why we are using 31,000 is because we have hard-coded the port. And why we have hard-coded the port? We have seen this because we are using kind cluster, and this is the configuration that we have done in kind, which is why we are accessing our node port service using localhost port 31,000. I hope you have a warm and cozy feeling about namespaces now. That's a wrap for this lesson. Today we learned how imperative commands can speed up Kubernetes workflows, from creating deployments and services to generating YAML files quickly. In our next lecture, we'll dive into manual scheduling and explore static pods, giving you deeper control over pod placement in your cluster. If you have any questions, feel free to ask them in the comments section and I will reply. If this helped, do consider liking, sharing and subscribing. It will mean a lot to me. Thank you very much.